Hello everybody, I'm Michael with Archimede Design and welcome to the channel. Today we're going to continue an example using Sheet Metal Design Workspace. There's another tool in there. Instead of using a profile, we're going to actually take a flat part and we're going to bend it. It's another approach to creating sheet metal design, but then also within the same design we're going to talk about perforations. So how do you design or have design flow for doing a perforation? So why would you want a perforation in sheet metal? Two great examples. One would be if you're doing a webbing area and you want to strengthen your design, but you need to give it some stiffness. So you can actually do like a hole cutout and then perforate it to give it some stiffness. Another area in which people are probably most familiar with perforations are when you have sheet metal steps or scaffolding or something where you have decking that has a bunch of holes in it and it's slightly raised up, which is going to give some friction or catch so it isn't so slippery. It's a very common thing you've seen in construction equipment and things of that nature. So we're going to do a part like that. So basically the design we're going to do is right up here in the corner, and we are going to do a flat piece of sheet metal, and we're going to put those features in there, and then we're going to bend those flanges. So the unfortunate thing is in Fusion 360, unlike maybe SolidWorks and some other tools, there's no add-in to do perforations. So you actually have to model them and come up with that design flow, how you're going to model that specific feature, and then how are we going to move it across that entire face. So let's get into that design and start something new here in sheet metal. Here we are in the design that I've done, and we're going to recreate this. And you can see that we've done this with sheet metal rules, 16 gauge again, like in our previous exercise. But yeah, this is basically a step that has 4 flanges around it with holes for attachments, and then these perforations. And specifically, you can see these perforations are knurled up a little bit. That's a common type of feature that you might want on the design in sheet metal. And you have to actually do a workflow and modeling to do this. There's not a tool that can, right now in Fusion, that can actually simulate this. So we'll start there. As you know, I like to define parameters when I'm doing the design, and specifically in this one, as we're going to go through this example, we're going to actually use some formulas in this because I want to do some calculations to determine what the number of perforations are that would say fit within this size of plate. So we're going to kind of go through an exercise like that. So I'm going to create a new component here. So as you know, I like to use parameters. So we're going to define these parameters. I've done this previously already. So we have the panel length, which is going to be 20 inches, the panel width, which is 9 inches. I've defined the thickness of the material as 16 gauge, which is about 0.06 inches, 0.0595. You can be pretty accurate here, but the display value is going to round up. I have mine set to just 2 decimal points. Probably maybe should change this to go to 3, but the feature length and width, and this is the feature of the protrusion that's going through, is 1 inch by 0.65 inches. And then the feature radius. So this is the radius of when that protrudes up through the metal, what that radius is, and you'll see when we design it. And then there's a particular angle I want that radius to go through before I cut it off. So that's 25 degrees. As I'm making these perforations across the sheet metal, I want them to be 9/16 inches apart, both length and width, so they're equally spaced across the thing. I'll talk about these other ones in a second. The flange height, once I bend this part, is going to be 1 inch, and I have an offset of 0.25 set. That's just allowing me to create some space between the edges of where the flange is going to be bent, so they don't get too close to the actual features we're going to do in the perforations. So some of the calculations I'm going to do here to determine certain numbers without me having to determine, do some other calculations later on. Knowing my width, my panel width of this design, and not taking into account the flange height I want to have, and dividing that by the feature width plus the gap that I want, I can determine the number of perforations I can fit across along the width of the panel, and then doing the same calculation, looking at the panel length and the feature length, and the same thing. There's these equations that we can then use to determine what the number of perforations is along the length. You'll see the equations are a little bit different. I have additional feature width added into this equation just to account that I need to have some spacing between them. So with that, it calculated 7 and 9. Now, once you do this, they may be if it's an even or odd number, when we end up doing this design, we're going to do this selection within doing an array copy of a feature of where I can turn certain ones on and off, because it may overlap in areas or not be exactly where you want it, but it's going to give you roughly an idea. And you can always, if you have to, when we define this later on, we can add one or subtract one if necessary. So these are definitely the features, numbers we want. If you want to copy these down or whatever, you can pause this now. But again, there will be a link in this in the end to a Google Drive that has this file in it, so you can actually pull in the file. Okay, now that we have this component created, it's important to do your sheet metal, anything you're doing in sheet metal in the sheet metal design space. You don't have to stay there, but if you're going to do any bending or profiling, you want to create your drawings in that space. You can convert things to the sheet metal part, but what it's going to do is it's just going to help kind of keep everything in order. So we want to be in the sheet metal space and then create our drawing. Let's do it on this surface here. And we're going to start rectangle center and just make this nice and symmetrical. Panel length by panel width. So that's the basic size of the panel. Keeping in mind that we're going to shrink this in when the things get bent in. So this is the interesting thing is when you bend things, when you bend things from a flat, you might not necessarily know exactly what the dimensions are going to be. They could be a little bit off a tolerance. That's why I always recommend, if you can do in a profile, but you could do this part in a profile first, because then you're making it where you want it to be, where you want it to bend to, and then flatten it from there. But in this case, we're going to do the opposite. Sometimes going from a flat pattern to a bent product, it's easier to do more complicated type bends. So I am going to have flanges on this, so I also need to account for those flanges. We're going to make this flange height here. Flange height plus offset. We want to do that offset so we have some room for the bend. So, and same one here. We'll make that equal to this. So you can see that I could just put in panel or flange height here plus offset, but I also can just set it equal to that same dimension. So we'll just make it equal to that one. And I do want a radius here, so I actually want to define that radius now. All right, so go ahead and finish the sketch. And let's just do an extrusion, make sure that everything's selected okay. And we're going to make this our thickness. So pick 16. And since I've predefined this already, this is steel and it's painted red. Powder coat painted red is what I have selected. So that's why it's defaulting to that color right now. All right, so this is our bare piece of sheet metal, and this is what we're gonna bend. And what we want to focus on now before we bend it is we're gonna put the actual perforations in. So the first thing is just to get the basic pattern. And if you're familiar with the patterns, that's the exercise we're gonna use. And finish sketch. Let's bring back that body and let's extrude that. You're probably asking, like, well, why didn't you do this array now? Why didn't you do the rectangular pattern now and do all that? Because we want to show this as a protrusion. I would have, I guess I could still do it in two different steps, but in this instance, I can do that array as a feature against a model, against a solid, versus doing it in the drawing. So we're just going to do the one here. Cut two objects, so go to the back, so it'll cut through. And now we have our nice little hole there. So now what we need to do is we need to define what this, how that feature is going to go. Like I said, there's not a sheet metal tool that can do a perforation and automatically bend those up. No lines or things we can select to do that. So you actually have to design it. And there are some challenges with this because we started with this whole definition. What we're going to do now is actually going to make it a little smaller. So just keep in mind that when you design something and you have this process in it, your actual whole feature, you might have to resize that to get it exactly what you want it to be, but this at least will simulate it really well for you. So we are going to do a new sketch, and we're going to do it right in the middle. And then you want to do project, include, intersect. Pick the body that we want. It's right here. We could select it, or you could select it over here. And it's going to create those lines. Let's turn the body off. You can see now we have reference lines. Let's turn on the axis, just so we can see the origin axis. So first thing I want to do is I know that this is the edge of that arc that's there, and it's the half the distance of what our feature width is. So I do want to create a reference line. I actually just want to do just this line. So just select it first, then do that. This is going to be feature width divided by 2. Feature. Okay, let's do the same thing. Whatever. So if you pick your offset first, it's going to do the profile that's there. But if you pick what you want to offset first, then click the offset, it will just do the offset on that line. So at the top is going to be our feature radius. And this is going to be the inside part of that radius. It doesn't really matter where you can click, you get that distance, and then we'll make sure it's vertical. And then we're going to do an offset to that. That's going to go through this point. So basically we're going to add thickness. Okay. And then what I want to do is I want to define like how far is this knurled up? Is it straight through all the way? Is it at an angle? We're going to do ours at an angle. So I'm going to just create another line here. And we're going to define that. And that was over here. So this is going to be feature degree. So it's 25 degrees. So you can see what we're looking at right here is this part of it right here. And here we have a profile. Now, next thing is to let's go back into that sketch. All right, let's bring our body back and zoom in on your feature. So you can see this is why we created this reference line, those reference points right there. So we're going to use the revolve on that feature. Our axis is going to be that. We want to do symmetric, 90 degrees. And that'll give us that side of the feature. And then what we're going to do is we're going to do the same thing over here. Repeat that. Turn drawing back on. It remembered the settings, same thing. And then we're going to do an extrusion from the ends of these to object to this face. And you can see in all of this as I'm doing these, I'm joining these on this body. Turn off our sketch. Well, actually, let's leave it there. So here you can see how I came up with this that protrusion feature is by defining the circle, the radius of the tool that would use to protrude it, and the angle in which I want it to end at, which will give me some height off the top of this to give, some grip. It also gives stiffness to this panel, and then they are revolved, and then I connect them using their two faces. So that basically creates that feature. So we have one in there. So the next thing is we want to use within the solid modeling space, even though this is a sheet metal part, it's got a rule defined to it. We'll get back to that. We're in the solid model space, and we're going to do this rectangular pattern. And what we're going to be doing is we're going to be doing a pattern of features. So we can select our objects. You can try to select them in here, but it's better to do it, to have your actual history line on and do it within your history. So we know I want that extrusion that we made. We want our two features and that other extrusion that connected them. So you can see it selected all of them. So now that we have this here, we have those selected, we need to pick the axis X or axis 1, axis 2 on that plane, the direction we're going to go. And this is where we put in those parameters. We had them calculated. I want, in this case, my spacing to be the distribution method. I want to turn suppression off in case I want to turn some of these on and off. And quantity is going to be based on the calculations we did in the parameters. So I want num perforation L. And that's giving me, along this line, the number that I want and the distance I want them to be is not the perforation gap or the or gap length or width. I want the space one. So here, see, I put in space horizontal. It picked those numbers, and I also want to do this symmetrically. So here you can see that it's symmetric. And there are two here that I do not want on. So we could just deselect them, or if we wanted to, we can go up here and do -2 and have them just eliminated from that. The other axis is going to be num perforation width, and it's going to be spacing width, and we also want this to be symmetric, and I also am going to do -2 because of the flanges that I have. Now, you might get an error. If you try to do identical, you might get an error. If you try to do optimize, you might get an error. It might still create it too, and it gives you other options. What we're going to do is leave it as adjust and see where we get what we get for this. Does the calculation, and there we go. So we have just created a perforated panel using a rectangular pattern. All right, the next thing we want to do is we're going to go back into sheet metal design, and we're going to actually now bend these flanges over. But before I bend them, I actually want to put some attachment holes on these flanges. So let's do, go into sheet metal. Let's do a new sketch on, let's do this sketch on the back surface. And the reason why I want to do this on the back surface is because when you're going to do bending, instead of using a profile, when you're going to do bending, it's going to bend it on that line. So whichever side that line is on is the direction that it's going to bend it above or towards. You'll see how it goes when we do it. But we're going to want to do it on the bottom because this is going to be, this in my mind would be the flat pattern surface that's stationary. So a couple things that we're going to want to do. Let's do a reference lines from here to here, here to here. And then let's do our offset that I want to have. Okay, I need to do some attachment holes. Let's make them 7/16. I didn't define these parameters, but we could. And then we'll mirror these to the other side. Repeat. In this case, you only need to mirror the outside two. We're not going to do the center one. It's there. It's okay to have it in the drawing. Let's just finish sketch. And let's extrude those. Cut them. Oops, I said we didn't need that one. to object. All right, so now we have our sheet metal part, kind of the flat pattern, finished. We have our knurling feature, we have our holes. But now we're, instead of working from a profile view to do sheet metal, we're going to do it from a flat pattern. And that's why we created this drawing here. This drawing here shows these lines in which we're going to bend that at. One thing to also keep in mind, if you're doing sheet metal design and you have multiple sheet metal parts within a design, be sure, and it's not the case in this model, before starting the actual design of it, create a separate component of it. Because if you have a sheet metal rule up on higher level components and you create another a component underneath it that is sheet metal, it'll have problems doing the calculations between the two because they're within the same component. So here we're simply going to go, we're in our sheet metal design, and instead of using the profile or the flange to do the profile, we're going to actually do bend. And here what you do is you actually are going to bend it along a line. And so we need to pick our stationary side, and we're assuming that stationary side is the bottom of this, and that's where we created the drawing. And then we have to select the actual lines that we're going to bend along. So if we select those lines, you will see it bends them. And if you look really close at it, that bend line is really at the bottom of that radius bend. So if you need to know where, or the width of this, or what the final width is going to be at the bend prior to actually bending it, it's going to be roughly what that bend radius is. So if you know what that bend radius is, you can account for that in your design. But in all reality, when it bends, it's not quite going to be the case, and I'm not sure how much it takes this into account, because when you do bend metal, it stretches some dimensions and things can move. So we'll click OK on that. Before I click OK on that, and the power of this tool, which is nice, is when you do it from a flat pattern, you can also do specific bend angles. So, what if this angle here was 45 degrees? It'll do it at a 45 degrees. So you can get very specific on the angles. And there's some other things here where you could pick where you want it to start, at the center, at the end. Where do you want that bend to be? So in this, it was at the start of the radius, like where it was there. Or if I wanted it at the center of the radius, or the end of the radius. So let's do end of radius on that one. So you can see that it shifted that in now, and now it's that line is at the end of the radius. Or you can do it in the middle. So all those things can impact how you might design it before you bend it. You can add corner relief or not, and if you need to override your radius. So I can override the bend radius instead of being the 0.06 that it is, we can make it 0.125, and you'll see it'll make it a little bit bigger bend radius. I think this is fine. Turn off our drawing. And then there it is. This is call it a step panel with a protrusion in it that is above the surface of the metal to give some grip when you step on it, with some attach points. So you can think of it as a stair or step on that goes up to scaffolding or fire exits. So there we have it. This is the flat panel with those protrusions. And again, you can use protrusions like this to stiffen anything like webbing within aircraft, but also lightning it as well. If you need to get it to be lighter but still stiff, you can put protrusions in this. You can make them whatever pattern you want. Definitely leave some comments if people have some thoughts or ideas on different patterns or methods or flow methods. This is how I would go about it. And again, so thanks for watching the video, and definitely click on the like button, and please subscribe if you want to get updates on my next videos that come out. And thanks for watching.